Awesome. Thank you all. And thanks for the introduction. So I'm really excited to be able to talk to you all about some of the work that's happening in my group in visualization at CSAIL. And this is work that a lot of different folks in my group have contributed to over the years, as well as a project that the SERC seed grant helped support. So I want to start by sort of casting our minds back to the pandemic era, right? We might remember being inundated with visualizations, right? The flatten the curve chart went viral. Ironically, not actually a visualization. It was not showing any data, but nevertheless, really bolstered a bunch of change at a societal level we'd never seen before. I think many of us were sort of frantically checking these kinds of dashboards, right? The Johns Hopkins one or, our local state government websites. And then the front pages of most major news publications were plastered with sort of wall-to-wall coverage of charts tracking a variety of different metrics from, case rates to death rates to vaccination rates when we had those. And these visualizations became such a part of the mainstream that they were even memed, right? So here obviously is the reason that some countries did better with the pandemic than others, right? Like how much bubble tea were we drinking as a society? And so as a result of sort of this outpouring of visualizations, lots of folks thought that this was data visualization's breakthrough moment, right? The folks who were producing some of these charts, were interviewed in high-profile publications, like here is John Burns Murdoch, an incredible graphics editor at the Financial Times. You might remember, these charts with an orange background that I feel like were at least everywhere on my social media feed. But sort of in parallel to this glowing coverage was, a set of experiences that people were having that is really well encapsulated by this tweet from Chancey Fleet, who is a blind technologist and researcher who works at the New York Public Library. So Chancey writes that today she read the alternative text for a chart on a local news site, and that alt text suggested that in New York City, the COVID case count had been steadily declining since April 26th, and that trend was continuing. And she thought, well, that can't be right. And so what Chancey did was emboss the graphic and confirm that actually, the alt text was wrong. And the reason that the alt text was wrong was, in this case, the person who had written the article had just sort of copied and pasted some boilerplate text to describe the chart, not necessarily double checking the facts. And Chancey was not necessarily alone in this experience, right? There are, by some estimates from the National Federation for the Blind, and this is pretty dated, this is from 2016, there are about 7 million people in the United States, about 2% of our population, that has some form of visual disability. And according to these estimates at least, visual disabilities refer to folks who either experience total vision loss or some pretty serious form of vision loss such that even wearing glasses or contact lenses, doesn't fully correct them to 20/20 vision. And this is also a good moment to just sort of like pause and think about, how we actually think about disability more generally. So typically, scholars think there are essentially two models of disability. The first is what people refer to as the medical model of disability, the idea that, being disabled suggests that there's something wrong with your mind or your body. And the critique of this approach is that it often focuses on designing technologies and interventions that are focused at the level of the individual person, right? Where often the goal is kind of implicitly to fix the thing that is wrong with the person's body. And I really like this description of what those sorts of technological interventions produce. So Liz Jackson is a disability rights activist, and she calls these sort of interventions disability dongles, right? I don't necessarily have a very positive affinity with my dongles. I think all of us who have Macs probably have a whole tray of different dongles that we have to kind of juggle, right? It's a well-intended, elegant even, yet nevertheless useless solution to a problem that disabled people never even knew that they had. And so in contrast to the medical model, there's a social model of disability that considers people to be rendered disabled because of choices and decisions that society has made. In essence, people with disabilities are not having their needs met. And so this approach recognizes that essentially all technology is assistive in some way, right? So I particularly like this chart from Microsoft's Inclusive Design Toolkit because it not only sort of surveys all the different senses along which someone might be disabled, but notes that disability doesn't have to be a permanent sort of state, right? It can be temporary or even situational, as in the case of a new parent or a distracted driver. And so as a result, the social model tries to make interventions at the level of infrastructure rather than the individual, right? So what do I mean by infrastructure? Well, a very commonly used piece of infrastructure, particularly by people who are blind or have low vision, is something called a screen reader. So screen readers are built into most modern operating systems. It's on Mac OS, iOS. Most modern browsers even have plugins for them. And essentially, like the name suggests, a screen reader narrates on-screen content. So I want to show you a quick demo from my postdoc, Jonathan Zong, who's been leading all of this work in my group for a few years about how a screen reader works.
A screen reader is an assistive technology that narrates on-screen elements as speech. The software provides a cursor which is shown visually on the screen as a black rectangle, and the user can use keyboard shortcuts to move that cursor and highlight different elements to be read out. I'll demonstrate that with my keyboard now.
Visited link heading level 1. Hi, we're the MIT Visualization Group. Visited link, home, space, visited link, publications, space, visited link image, CSAIL logo, heading level 1. Rich screen reader experiences for accessible data visualization.
So you'll notice that the narration was actually pretty fast, right? But what Jonathan did there was actually slow the speed of the narration way, way down because we imagine that most folks in this room aren't used to this kind of technology. But actually, proficient screen reader users have that speed sped all the way up. And so what does it look like when a screen reader user experiences a visualization? Let's take a look.
Joe Biden image 306. Joe Biden. Kamala Harris. Donald Trump image 232. Donald Trump. Mike Pence. 1 votes. 1 votes. 20 votes. 4 votes. 2 votes. 11 votes. 10 votes. 10 votes. 16 votes. 6 votes. 14 votes. 4 votes. 5 votes. 29 votes. 4 votes. 7 votes. 20 votes. 3 votes. 13 votes. 12 votes. 10 votes. 11 votes. 9 votes. 55 votes. 7 votes. 3 votes, 16 votes, 3 votes, 29 votes, 6 votes, 9 votes, 3 votes, 3 votes, 5 votes, 6 votes, 38 votes, 11 votes, 3 votes, 9 votes, 18 votes, 7 votes, 3 votes, 15 votes, 2 votes, 3 votes, 10 votes, 6 votes, 8 votes, 8 votes, 11 votes, 6 votes, 6 votes, 4 votes, 1 votes, 1 votes, 1 votes, 81,283,495 votes, 81,283,495 votes, 51.4%. Group. 270 needed to win. 74,223,755 votes, 46.9%.
So notice that, it read out that whole string of essentially nonsense, right? But the person who made this video, Sarah Fossheim, she wasn't actually tabbing around, right? Her cursor was actually on the same node for that entire, minute and a half long video. And here, this is actually a pretty good experience, if you can imagine that. Here is often what happens with most visualizations.
Image. 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 One face. Image. Logo other. Image. Image. Logo other. Image.
And so we kind of get the point, right?
Image.
But I often like to let these videos play through because
Image.
I want us to have a really visceral experience
Image.
of how frustrating
Image.
the experience
Sign.
of using the
Image.
internet with a screen reader can be for folks, right? I think
Image.
for us, it's kind of amusing because this is just a cute
Image.
1-minute video and a talk. But imagine if the internet was a series of images just being narrated out to you like this, right? Incredibly, not just frustrating, but you're locked out of a pretty key information modality, right? How many of us were making decisions about whether we should go out or not in the pandemic,
Image.
and you would be locked out of
Image.
that modality entirely and just hear image, image, image.
Image.
And so the challenge with representing visualizations in this way is that as you're noticing, right, the pattern of reading things out has to be linearized for a visualization. But all of us probably read visualizations in lots of different ways. Some of us might look at the title first, maybe look at some other textual annotations. Others of us might look at the trend that the visualization is trying to convey. And so part of the challenge with visualizations currently is that the current best practices don't represent that diversity very well. At most, you might get a piece of alternative text like this that tries to summarize the chart and then gives you a link to a data table for further sort of analysis. And when we talked to blind people about this, they talked about how they felt like they were at the mercy of the alt-text writers who made assumptions about what sorts of data they would be interested in. Another person said that I would like to have time and space to interpret the numbers for themselves, right? Blind people want a sense of agency and to feel like they're in control of their experiences. On the other hand, I'm sure none of us would want to actually page through a whole data table to understand who won the election, right? There's 393 rows. I would never scroll through all of it. And because everything is being read out linearly, you have to sort of hold all of this information in your head to have any sort of ability to sort of make some insightful observation. And so instead of this very linear structure, my students and I have been thinking about a much more hierarchical text-oriented way of depicting visualized data to screen readers. And the way to think about this hierarchy is at the sort of topmost level, you get some sort of summary of the chart, right? So a scatter plot with some data along the x-axis, some other data along the y-axis. And then with the down arrow key, you can essentially descend into different levels of these hierarchies based on visual properties like the x-axis, the y-axis, so on and so forth. And you can keep drilling down into this chart, again, continuing to make use of visual affordances like the major axis ticks, the minor axis ticks, and so on and so forth. So let's take a look at an example of what this looks like.
Let's say I'm using a screen reader and I encounter the scatter plot on a page. With Ollie, at first I'll hear an overall description of what the scatter plot is.
A scatter plot with axis split per length, mm, and body mass, g.
Let's say I want more detail about the scatter plot, so I can press the down arrow key and expand this structure to the next level where I can get information about the different axes and legends of the chart.
X-axis titled flipper length, mm, for a quantitative scale, with values from 172 to 231.
And once I'm on this level, I can press the left and right arrow keys to cycle through the other elements on this level.
Y-axis titled body mass, G, for legend titled species, for an...
Let's say that I'm interested in getting more detail about the x-axis, so I can navigate back over to the x-axis with the left arrow key and then press down again to descend into a further level of detail.
Y-axis titled, x-axis titled...
Now down arrow to expand.
1 of 7, flipper length, mm, is between 172 and 180, 7 values. Press T to open table.
And on this level, I get information about the intervals along each axis.
2 of 7, flipper length, mm, is between 180 and 190, 3 of 7, flip 4 of 7, 5 of 7, 6 of 7, 7 of 7.
I'm going to demonstrate here an alternate navigation technique that we're calling spatial navigation. So I'm going to use the WASD keys to move along the grid of the scatter plot.
5 data values in the interval body mass, G, 2,500, 3,000, flipper length, mm, 180,190. 60 data values in the interval body mass, G, 79 data values in the 10 data values in the interval, 25 data values in the 32 data values in 0 data 3 data values in the 23 data values in the interval body mass, 30 data values in the interval body mass.
So here, by moving around the grid, I'm able to build more of a mental picture of how the data values are distributed spatially.
And so you can see, we've taken that idea of alternative text and made it a much more sort of dynamic experience, right? Folks can drill down into different levels of detail. They can move around a scatter plot almost like they would with their fingers on sort of a tactile graphic. But one of the things you might notice is all the textual descriptions right now, they're kind of bog standard, right? There's not a lot of richness or particularly insightful things. And you couldn't expect any human visualization designer to sit there and enumerate, every sort of interesting thing in this huge sort of space. So this is sort of almost a perfect opportunity to intervene with some generative AI to think about, what richer textual descriptions of visualizations might look like. So here I'll turn things over to Isabella Pedraza Pineros, who's been exploring this work as part of her master's thesis.
In this version of Ollie, we've added something called data highlights. And if I navigate into the data highlights by pressing the down arrow key, it's going to show us semantically meaningful groupings of data that we've generated through calls to ChatGPT.
Data highlights for highlights. 1 of 4. Efficient foragers. This group combines mid-sized flipper lengths with a healthy body mass, indicating penguins that have adapted well to a range of environments, being able to swiftly navigate open waters while also capable of agility. A combination suited for efficient foraging. Flipper length, mm, is between 191 and 210 and body mass, g, is between 3,301 and 4,385 values. Press T to open table. Select.
So in that description, we heard about a grouping called efficient foragers. And the system provided some reasoning about how certain values of flipper length and body mass might indicate that certain penguins are part of this group. And if you look over at the visualization, you can actually see the visual representation of this efficient foragers grouping that we've highlighted to draw an analyst's attention to this grouping of data. We can also explore to find more about other data highlights.
2 of 4. 3 of 4. Antarctic marathoners. Long flipper lengths paired with a robust or athletic body mass may indicate penguins that are specialized for endurance swimming in Antarctic conditions, capable of long-distance hunting in open waters. Flipper length, mm, is between 211 and 235 and body mass, g, is between 4,301 and 6,496 values. Press T to open table.
I mean, I love the titles that ChatGPT is giving to these different kinds of penguins, right? Antarctic marathoners, and turns out so did participants in our user studies. So one person said that they really appreciated being able to drill up and down these different layers in the grid because it gave them a really different way of thinking about data and visualization. Some of our participants, all of whom were blind, some of them said that with our system, this was the first time they actually understood what a scatter plot was showing. They never really understood what a scatter plot was, and that was kind of a really special moment. Another person told us that they were able to think much more in spatial terms, right? I'm moving up and through the grid. I'm drilling down just to that square to get some particular information. Another person mentioned how things like the data highlights it boosted their sense of confidence, right? Their ability to actually think in terms of the data. And a final person, said that it made them even much more interested in exploring the data. It opened their minds to particular kinds of insights or trends that could be unlocked through the data. And so we've released this toolkit, as an open source project called Ollie. These LLM extensions will be coming soon. And with that, I'm very happy to take all your questions. Thanks very much.
Thank you very much, Arvind. Questions?
Hi, thank you so much for this talk.
Absolutely.
I was wondering, because these large language models are prone to, for example, hallucinations, where they create false data or maybe describe things in a way that is not intended, if there was any sort of metrics or ways in which you decided to go about that or to combat against that?
Yeah, absolutely. So one of the ways that we produce those statements with ChatGPT is we give it the context of the data that it's looking at. So we're not sort of prompting it with no guidance whatsoever. The fact that we provide that data often kind of constrains its generation. Yeah, that's not to say there's no chance of it hallucinating. But at least that captures sort of a broad bucket of them. Yeah.
Okay, further questions?
Oh, right here.
Thank you so much for your talk. I was also just wondering, expanding on metrics for accuracy, are you doing any validation to assess how accurate the model is, or prevent any hallucinations from happening?
Yeah, absolutely. So we haven't yet, but it's certainly something on our agenda. And so right now, one of the things we're sort of curious about is, when do how should the text be worded to prompt the user to actually consider verifying or validating? So are there different ways that a particular description could be worded to encourage someone to verify or validate it? When, do they want that sort of verification, validation, things like that, yeah.
Thank you.
Just thinking, one can imagine giving the user the ability to instruct with verbal instructions that are somewhat flexible. Have you considered that as well?
Yeah, so that's a really great question because, one of the interesting things about visualization is often we use it to ask questions we don't even know we have, right? And so a lot of the use of visualization is often more for discovery and sort of serendipity and things like that, where you almost don't know what it is you're looking for, so you wouldn't know how to sort of formulate the question. And so that's why we focused on these sorts of use cases where we're trying to use generative AI to sort of accelerate that knowledge discovery process. You could certainly imagine augmenting this interface with some sort of Q&A panel or something like that, certainly, yeah.
I was wondering what's the main demographic that's testing? Because I feel like that would affect the way they perceive things also.
Yeah. So the main demographic we've been testing with are sort of full-time screen reader users. So they're folks who use screen readers day in and day out because they have some form of fairly serious visual disability. Most of our folks were fully blind, but some fair portion of them have some kind of low vision. So they use screen magnification alongside a screen reader or things like that. Yeah.
Kind of coming off of that question, did you look at like their maybe like the people's like education levels and ability to interpret, like just since it's about interpreting data, like are they? I feel like that has a lot to do. Can vary
Absolutely,
a lot.
Yeah. So we had a pretty diverse range of sort of familiarity and experience with data. We had a handful of folks who do professional data work, as well as folks who don't use it at all. And so I think those final two quotes were from folks who had much more minimal experience and familiarity with data. So that's why it gave them a boost in confidence. It increased their interest in engaging with data because they're the set of folks who would not be sort of thrilled to just have a link to the raw CSV and sort of like move through the table, right? But on the flip side, they also aren't satisfied just being told like, here's the alt text, like here's what the summary of the chart is, right? So it's trying to meet those people where they are in terms of their data needs as well, yeah.